this example, we will solve an application using the Pythagorean theorem. Our problem states that we have one leg of a right triangle that is 2 feet longer than the other leg. And as you know, the vertical and horizontal sides of a triangle are what we call legs, leg A and leg B. If the hypotenuse is 6 feet, the hypotenuse is the slanted side of the triangle, and that is 6 feet, then what are the lengths of the legs? So we're going to take our diagram of the Pythagorean theorem, and again, because I know this is leg A, this is leg B, and this is side that we call C, the hypotenuse, I'm going to take each of these expressions and insert that into the Pythagorean theorem to find the lengths of both sides. In my formula, I will replace A with X, and that variable gets squared. I will replace B, or the second leg, with the expression X plus 2. That expression gets squared. Set equal to 6, which also gets squared. So each leg has been squared, and the sum of those squared legs is equal to the square of the hypotenuse. So we're going to simplify our equation because as we see it just turns into a quadratic equation that we're going to solve using the quadratic formula. So an x raised to the second power is x squared. A binomial squared or squared binomial simplifies to x squared plus 4x plus 4, and 6 squared is 36. Now I'm going to combine my like terms. X squared plus x squared is 2x squared plus 4x plus 4 equals 36. And I notice that I have a GCF in my quadratic equation on the left side, so I'm going to factor out 2 because it's common to all three of my terms. So this leaves me with x squared plus 2x plus 2 equals 36. And since I factored out this GCF of 2, I'm going to go ahead and divide this 2 by both sides of the equation. And that simplifies to x squared plus 2x plus 2 equals 18. Now, to solve a quadratic equation, I need to get the right side of my equation equal to 0. So I'm going to subtract this 18, and that leaves me with x squared plus 2x minus 16 equals 0. So we have a quadratic equation set equal to 0, and now we're going to solve for x by using the quadratic formula because unfortunately I cannot factor this equation, but I know the quadratic formula will work every single time. So to use the quadratic formula, we need to know the values of our constants a, b, and c. A is positive 1, b is 2, and c is negative 16. And the quadratic formula says that x is the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we're going to substitute the appropriate values and solve for x. The opposite of b would be negative 2 plus or minus the square root of 2 squared is 4 minus 4 times a, our a is positive 1, c is negative 16, all over 2 times 1. Again, we'll keep on simplifying until we get to a point of solving. 4 minus 4 times 1 times the negative 16 becomes positive 68 divided by 2. I can simplify underneath my radical here. 68 has the factors of 4 times 17. And I now can find the square root of 4, which is 2. And in my last step, because my denominator here is 2, I can reduce it with the negative 2, and I can also reduce it here with the positive 2. So this simplifies to x equals negative 1 plus or minus the square root of 17. But before I walk away from this answer, let's go back to our application and make sure that this answer makes sense. If the legs are -1 plus the square root of 17, that is going to give me a positive value for the length of my leg. But if I use -1 minus the square root of 17, that is going to leave me with a negative value for the length of my leg. And as you know, in an application, it has to make sense. And it would not make sense for the length of either side of my triangle to be a negative value because we don't measure distance or lengths in negative numbers. So the true solution is -1 plus the square root of 17. So let's leave our problem as we were asked in the correct units and in the correct expression. So if leg A is equal to x, we have just found that x is -1 plus the square root of 17. And if you get your calculator and evaluate the square root of 17 and add a -1, you will find, and I'm going to approximate that to the tenths place, that leg A is approximately 3.1 feet. And leg B, in our expression, we have x plus 2. We were told that the other leg is 2 feet longer. So x plus 2 means that we would take the approximation of 3.1 feet plus 2 more feet, and that means that leg B is 3.1 plus 2, which is 5.1 feet. So leg A is 3.1 feet and leg B is 5.1 feet. And this is how you solve a problem of an application using the Pythagorean theorem.